Hello everyone. Today I am going to give you another very important presentation on the topic of pulse position modulation, that is in short PPM. So in my previous presentation I give you the detail about PWM, that is the pulse width modulation. It is another pulse modulation, that is pulse position modulation, that is the PPM. Now this is the outline of the presentation, that is I give you the what about of PPM, then modulation of PPM, demodulation of PPM, and it's very important to comparison between PAM, PWM and PPM. So now let's start. What is PPM? PPM is a pulse modulation that is relative to its unmodulated time occurrence, and it is varied in accordance with the instantaneous value of the message signal. That is, we see that in PAM amplitude is variant with the instantaneous value of the modulating signal. In PWM, width of the signal is variant with the instantaneous value of the PAM signal, that is the modulating signal. And in PPM, position, relative position is in according to the time occurrence is varied with the instantaneous value of the modulating signal. So these three are the most used pulse modulation in accordance with amplitude, width and position. So now this is the PPM modulation technique, that is the generation of PPM. In the first diagram you see that is the PPM generator, and in the second diagram you see the waveform of PPM generator, that is the output. So you see here that PPM generator consists of differentiator and monostable multivibrator. So the differentiator generates positive and negative spikes corresponding to leading and trailing edges of the PWM waveform. That is, now PWM is your pulse, that means this is your pulse PWM. So PWM is variance with the width. So the differentiator generates positive and negative spikes corresponding to leading and trailing edges of the PWM waveform. Here diode D1 is used to bypass the positive spikes, and the negative spikes are used to trigger the multivibrator, that is using IC 555 timer. The monostable multivibrator then generates the pulses of same width and amplitude with reference to the trigger to give the PPM waveform, and so as shown in the figure. So you see here, this will be the PWM waveform, that is the width is variant with the instantaneous value of the modulating signal, and this is the trigger pulses which is generated by the negative spikes. So when these two are passed through a monostable multivibrator, then it generates a pulses of same width and amplitude. You see this width are the same of these pulses, and amplitude is also the same with reference to the trigger to give PPM waveform as shown in this figure. That is, you have to take it either in the leading edge of the PWM signal or trailing edge of the PWM signal. Now, this is the generation technique of PPM, which I discussed in showing the block diagram. So now demodulation of PPM. So here you see in the block diagram that PPM signal is now passed through a PPM to PAM converter. Then it is passed through a low pass filter, and we get from the output of the low pass filter is your modulating or message signal. So this utilizes the fact that the gaps between the pulses, the transmitter is pulses of a PPM signal contain the information regarding the modulating signal. During the gap A and B, that means during this gap AB between the pulses, the transmitter is cut off and the capacitor C gets charged through the RC combination. Here R is here. So during the pulse duration of BC, that is this one, the capacitor discharges through the transmitter, and according to the transistor, these transistors, and the collector voltage becomes low. Thus, the waveform of the collector is approximately a sawtooth waveform. It generates a sawtooth waveform whose envelope is the modulating signal. When this is passed through a second order op-amp, this is the second order op-amp, low pass filter, it acts like a op-amp. This second order op-amp acts like a low pass filter. We get the desired demodulated output. So we get this demodulated output. So it is very simple. That's to generate a PPM and to demodulate a PPM. It is very easy. Now, this is the thing which I already discussed to showing the diagram. Now, advantages of PPM. Like PWM, in PPM amplitude is held constant, thus less noise interference. That means in PPM amplitude is held constant, so noise is very less to interference with your original message signal. Second point is the signal to noise separation is very easy. You can separate noise and signal easily. Third is because of constant pulse widths and amplitudes, transmission power for each pulse is same. So constant pulses, width and amplitudes, so it take transmission power for each pulse with the same value. What is the disadvantages of PWM? That is, synchronization between transmitter and receiver is required, and large bandwidth is required for the PPM as compared to PAM. So these are the two major disadvantages using a PWM or rather PPM. So these are the comparison table between PAM, PWM and PPM. So PAM, in the first point, PAM is the amplitude of the pulse is proportional to the amplitude of the modulating signal. In PWM, width of the pulse is proportional to the amplitude of the modulating signal, and in PPM, the relative position of the pulse is proportional to the amplitude of the modulating signal. In the second point, the bandwidth of the transmission channel depends on the width of the pulse in case of PAM. Bandwidth of transmission channel depends on rise time of the pulse in PWM, and in PPM it is same, that is bandwidth of transmission channel depends on rise time of the pulse. In the third point, the instantaneous power of the transmitter varies with amplitude of pulses. In case of PAM, the instantaneous power of the transmitter varies with width of the pulses in case of PWM, and the instantaneous power of the transmitter remains constant with width of the pulses in case of PPM. Fourth point, noise interference is high in case of PAM, and in case of PWM and PPM, noise interference is very less, that is very minimum. In the fifth point, in the PAM, the total system of modulation and demodulation system is very complex, and in case of PWM and PPM, it is very simple. And the sixth point, in case of PAM, similar to amplitude modulation, in PWM it is similar to a frequency modulation, that is FM, and in case of PPM it is similar to phase modulation, that is PM. That means PAM is like AM, PWM is like FM, and PPM is like PM. So what we learn from this presentation, that is we learn all about the PPM, the modulation technique of PPM, demodulation technique of PPM. Then we learn about the advantages and disadvantages of PPM, and it's very important comparison table between PAM, PWM and PPM. So I hope you enjoyed the whole presentation and you learn about the pulse position modulation very well. So thank you very much, and that's all for today.